Today, we're going to build a national model using Meridian marketing mix modeling, the new open source library developed by the marketing science team of Google. It's going to be a step-by-step tutorial from the moment in which we use the e-commerce data. We upload it, inserted inside of this notebook. We're going to see how to run an exploration analysis and how to run hypothesis from it, how to set priors, and how to train a model and interpret the insights. At the end, we're going to show you a little sneak peek on how to leverage the budget allocator in order to make better decisions in the distribution of your budget and see the actual improvement that can be generated from these applying this framework in your business. Everything they're going to share is going to be free, and you can actually use it and access it in the links and in the description of this video. So I'm Gabriel Franco, CEO and co-founder of Cassandra, and before we dive into it, a word from our sponsor. To the sponsor of this video, Cassandra, we allow us to do self-service marketing mix models, to build the model and assess the ROIs of each campaign types, assess the impact of any marketing activity in your marketing channels, assess diminishing returns of each channel, and what are the effect over time of your spend volumes, and then give you an assessment and a tool to plan your marketing investments at a monthly basis. And it allows you to calibrate the model over time with incremental tests. So analyze the results, unlocking what is being the incremental output of your incrementality test. And you can use this insight in an ongoing basis to calibrate your MMM, to make it more robust and more accurate into predicting future outcomes. Back at us. So what we're going to do today we're going to import all these libraries from Meridian and TensorFlow probability in order to enhance and make everything simpler downward. But let's start from the dataset. I'm going to share with you the dataset, which is a dataset we collected. It has media factors, organic factors, and context factors. Okay, back at us. What we do here is we import the data using pandas and automatically collect all the variables that have spend or cost or budget inside of their name in order to cluster everything into a list of features. This list is the media. Now we want to exclude all the media columns that have only zero value. So we exclude them. We manually import the organic fields, which are emails. And we always do that, the date week into a datetime format using pandas. Automatically select the column that has revenue in its name in order to import the list for the Apple variable. Now, these are our variables. This is our data set. Now, what we're going to do is we're going to do and run an EDA analysis. We're going to select and run a check on the spend share. So we want to understand where we're allocating the most money, because the MMM can be biased based on how much we're spending in each channel. Now we can see that Snapchat is only spending 3%. Facebook ads conversion cost is spending only 4%. These two can have a lot of uncertainty. It can lead to bias analysis because we don't spend enough in order to see a statistical significant change in the Apple variable. Then we have Google Ads video cost, which is really, really low. It's 0.8%. It's always better to avoid inserting it. But for this example, I'm not going to dive into every details. I'm just going straight forward to the modeling. The second step, we want to check a correlation analysis. We want to see what are the variables that have the highest correlation with the Apple variable and which ones do not. So we can see that Google Search Others has a 60% correlation with the Apple variable. Search Women 54. Google Search, these variables tend to have a negative correlation effect with the Apple variable. What it can happen is that the impact of this variable can be really, really low. So this is the intuition and that we might derive from this insight. Scrolling down, we can see the impact correlation to check that there is, other than the Apple variable and the input variable, there are a lot of other correlation effects inside. For example, Google Search Women, Google Search Other, and Google Search Men are highly correlated with each other. So we need to consider that. And according to the multicollinearity analysis, we can use the VIF analysis that uses a metric. We can derive and say all the variables that have a VIF value under 5, they're really good. If it's above 5, we need to take that into consideration and see the result as bias. Now, it can be biased because these models, when they train on multicollinear data, let's say, for example, you always increase the budget on Facebook every time you've increased on Google search, for example, the model will be able to understand the aggregated contribution of these two, but it's not going to be able to separate them. So this is the main difference. And this is why it's extremely important to run this EDA analysis before you start the modeling. You want to check what variables might have biases inside. Now, the first thing that we do is I've created this function in order to map all the costs and impressions mapping that is required for Meridian. So Meridian needs to have, in the cost mapping and impression mapping, name of the variable, cost with the name of the variable, and that's it, in order to import the data inside of the library. So I've created this simple function that maps everything automatically in order for you not to always do it manually. It's a really pain in the ass if you do it manually. So what it does here is it collects all the variables that have cost at the end and syncs the snapshot cost with the name Snapchat, Facebook ads conversion cost with Facebook ads conversions, etc. Now, in this example, we don't have the impression mapping. So even though the function is here, the impression mapping doesn't do anything, just for you to know. Now, these are these are variables that we're going to use later, okay? Remember this. These are going to be used later, this mapping. Now, before we dive into the modeling and everything inside of the model, I created a little seasonality function that is going to derive seasonality and patterns that repeat themselves year over year as an external variable that we can model as control. This e-commerce specifically is really seasonal. Depends a lot on seasonality, so including the seasonality inside of this analysis, it's a must. We need to include it. This function is really, really easy. So it uses a stats model in order to decompose the seasonal effect of our data set and our e-commerce revenue over time. So we use it and we have our seasonal effect. If we check the data set, in fact, we can see that seasonal e-commerce revenue has a multiplicative effect here that we can see record by record. It's automatically added. Now, what we do is we import data inside of core columns. Core columns is a function from a method of Meridian that allows us to import all the variables inside. We define e-commerce revenue, and we define the control variables. The control variables are all the variables that might have a positive or negative effect over time that change the baseline in this case. So what happens here is that events and seasonal e-commerce revenue, which is the seasonal component of our function above and seasonal component of our e-commerce revenue, is included there. This control is going to change the contribution of the baseline. Now, because Meridian has time varying baseline. Now, we add in the media, we should have insert all the names with impressions and the media spend, all the names with the cost or the spend. But in this case, we don't have impression. So even though you don't have impression, you can actually import all your data. Just import the same list, both in media and in media spend. Then in organic media, we have the list of organic variables, which is emails delivered. We're going to insert this variable into the loader data frame data loader. So in this case, we define the names of the variables that we're going to import. In this loader, we're going to actually load them. So we define what is the data frame. We define what is the type of the output variable in order to calculate the right ROAS, ROI, or cost per conversion. Then we insert code columns, and again, in this case, we don't have the mapping for impression. So both for media to channels and media spend to channels, we're going to insert the same list. This list is the list that we've actually created here, cost mapping. So this is why it was important later, just for you to know. Now, we've loaded the data set. And if we want to see it is an next array data set in which it has multiple dimensions. It allows us to see all the values in here in this format. And it has some settings inside of the data set. Now, we've done the exploration analysis. We've done the data import and loaded all the data inside of the framework of Meridian. The next step is going to be setting up the ROI prior. Now, the framework of Meridian uses log normal distribution priors. And So what it means is that we need to translate our ROI mu and ROI sigma into log normal distribution terms. So for these reasons, I've created this really simple function, guys, that is called estimate log normal distribution, in which you can insert the actual ROI that you have in your dataset, or by running an incrementality test, you know that a specific channel has a specific ROI and a specific confidence interval. You can insert it here, and it's going to automatically translate these numbers into ROI mu log and ROI sigma log. So according to the log normal distribution. So if we run this, right? So we define the function log normal distribution. We define the ROI needs to be 5, the mean, and the sigma, which means that the amount of variance that this value can have is 4.5. So the ROI usually is between 0.5 and 9.5 in this case. It transforms into log normal distribution. If you run it, we see that the log normal distribution of these two values is 1.3 and 0.7. Now, in the next step, we define and insert the Meridian prior. So we define the prior with the log normal distribution, and I've tried to just insert ROI mu log and ROI sigma log, but I always have a TensorFlow error. This error is solved by copying and paste the actual number that come out here. I don't know why. Anyway, so we define the priors and what the tree represents, and they represents the context, the constants ROI m. We define the specs of the model, inserting the priors inside of the specs, and the specs then are used into the method Meridian, in which we need to insert both data and the specs of the model. Given that, the only thing that we need to do is sample the prior to be sure that the priors make sense and there are no errors. And then in here, we run the sample posterior. So in this case, what happens is we call again my error, but we repeat the code. Model Meridian is called. We sample the prior, and then I've created a bar plot that you can use in order to see the progress of the training of your MMM. In this case, I'm going to be using the same standard default metrics. There are suggestions in the documentation of a Meridian. Now, we run this training, and for us, it lasted 2 minutes with a MacBook Pro M3 Pro. And GR square was 60%, MAPE was 31%, and WMAPE was 27%, which is interesting. It's not the best model, and now we need to check why. So scrolling down, we have actually the plot trace of all the training that we did, and we see the distribution is really similar to our prior that we set up. So we scroll down. What I want to show you is the model diagnostic. The first thing that we need to do is understand the hard hat. The hard hat need to be around 1, or they need to move really little, because if they move a lot from the hard hat, it means that we did not reach convergence, and it means that we don't have not even a robust model. It's that the model is just wrong. So we always need to be sure that the model reaches convergence, and we can check that by taking a look at the hard hat that need to be around this value 1. If they're a lot lower than 1 or a lot higher than 1, like 1.1 or 0.9, it becomes dangerous. So you need to be careful. Now, let's see the analysis. So the model actually is really good on average. So it can predict really good these spikes. It has hard time understanding these 2 spikes here, which are, I think, in January or the end of the year. So probably the 60% R square is driven by the lack of having holidays effect inserted inside of the model, just for each. We can see that the baseline moves a lot, and the baseline is affected by the seasonality effect that we actually created. If you A/B test this and you exclude the seasonal effect or include it, you're going to see a huge increase in R square and a huge decrease in MAPE, so in error that we see in the model between the prediction and the actual value. So we understood that the training that we did led us to a 60% R square model with approximately 30% error. And we saw that the reason why we got those metrics is because there are 2 or 3 spikes in which that are considered outliers. These are outliers probably because they're driven by factors that we did not include in the model. So the lack of feature in this case is the first reason of why we did not achieve an 80% MMM, 80% R square MMM. Scrolling down. So in here, we have the visualizer media summary, and this is a super smart thing to have. I've said in the previous video that Meridian is optimizing everything for user experience and sharing the input of the models they are created. And this is how they do that. So they summarize everything into a data set, which is really simple to read, in which we have channel distribution, the impression, percentage, spend share, spend, CPM, incremental outcome, contribution. We have all the values summarized in here in order to plot everything else. So probably all the plots that I'm going to share with you right now, they're derived by this data set. And this is super smart to have. It means that you can actually export it and plot it into a Looker Studio if you want. Anyway, scrolling down, one thing that I wanted to check with you guys is that the ROI prior is always around 5, right? It's over 4.8, 5.4, 5, that's it. And the confidence interval is generally higher in the prior rather than the posterior. So what happens here is that we have a 5.4 prior on Snapchat between 1.2 and 15.6, while the posterior is 2.9, and its ROI goes between 0.8 and 6.5. So what happens with this training is that the confidence and credible intervals get stricter with the historical data that we have. Probably can be improved if we increase a little the number of iterations that we create on the number of chain. But anyway, scrolling down, let's analyze this model. In this example, we plot the waterfall decomposition, and we see already that the variable that had the highest correlation, the highest spend shares, gets a lot of value. In this case was Google Ads search others. Now, it had the highest spend share and the highest correlation. So, and it was also multicollinear with other Google Ads. So it's not abnormal to have this result. Now, because of the spend share volumes, I would strongly suggest to calibrate it. Would be the first channel to calibrate through an incrementality test. Now, we see that the emails have pretty good contribution, 185K of revenue. And Google Ads video has low contribution. Google Ads search kits, low contribution. And these were also the ones that had the lowest spend share. So it makes sense. Let's scroll down to see the distribution, right? So 51% of the overall contribution is attributed to the baseline, while 49% is attributed to the media, which is really interesting. I mean, it means that most of the variable, like most of the sales and revenue that we generate, is driven by seasonal effects, events, and other external factors and the traction of the company. The other 49% is actually incremental. So this is the assumptions that we're making when we train the model. And based on these assumptions, we need to understand how to calibrate it. Now, we scroll down to see what are the variables with the highest ROI. So the highest ROI, because of the correlation effects that we saw before, is Google Ads search others. And it has a 3 times higher ROI, which is it might be a red flag, or it might be true. The only way to know for sure is by running a conversion lift or a geo lift, a deprivation test on this channel. Now, the other channels are fairly around the same value. So between 1.9 and 4.1, which makes sense overall. Let's scroll down to see the bar plots with the credible intervals. And as you can see, the highest and widest credible intervals is Google search others, which confirms the thesis that this needs to be the first variable, the first channel and campaign type that we test. Now, there are other variables like Google Search Man and Facebook Ads brand awareness that even though they have a high spend share, they have a low ROI. It means that we reached diminishing returns effects here. Well, in here or not. Let's see the ROI versus the effectiveness. So in here, we have a linear correlation between variables, between the effectiveness in terms of percentage and its ROI. The ROI that has the highest value is also the highest, it has the highest ROI and the highest effectiveness, which makes sense. Well, there are, like for example, the gray one, which is Google Ads shopping. We spend really little. It has a really low ROI. It's ads shopping. And then we can see the marginal ROI. With the marginal ROI, we can actually spot opportunities of spending more money. And we can see one here. So this channel, which is the Facebook Ads brand awareness, or actually Google Ads video, is the channel that has the highest marginal ROI among all the other variables, which means that it's better to spend €1 more here rather than the other channels. And you can spot it by checking the variables that move from this trend line, this diagonal trend line on the left, because if it goes on the right, it's not good. So what we do here is we want to plot the diminishing returns curve. And we want to see if Google Ads man, as you can see here, it reached really quickly a diminishing returns effect. It's almost horizontal here, while in here was a lot more vertical. And Facebook ads brand awareness. Facebook ads brand awareness. Oh yeah, in here. As you can see here, the hypothesis that I had before that both Facebook ads brand awareness and Google search man as have reached diminishing returns is true. As you can see, this curve reaches diminishing returns, and now if you increase the money in the investment here, the incremental ROI becomes really low. The marginal ROI becomes really low and lower the more money we invest. While there is Google Search Others, which is this one, it's still linear. I mean, it saturates, but not enough in order to compensate it, to actually say that it's not effective. Now, one thing though, even though we see these diminishing returns, the credible intervals around it are really wide, which means that it's needed to have calibration inside. We need to insert this knowledge inside of the model in order to make the model make sense about this channel, which is the highest spender and the most important one. Now, diminishing returns are not everything. Ad stock effect are, on the other hand, really, really important to know. Now, what we want to check is what is the difference between the prior that we set and the posterior, because we want to see how well we reduced the amount of uncertainty that there was inside of our model. Now, in here, Facebook brand awareness is pretty linear. We reduced that by a little. As you can see here in pink, we have the prior, and in darker pink, which is blue, we have the posterior. The posterior credible intervals is still super high, but it makes sense. Same thing for Facebook conversion. Facebook engagement actually got wider, probably because it has a really low impact. Then we have this channel, which is Google Ads Others, which is the highest spenders. It says that the actual contribution, the actual effect over time is closer to the moment in which I spend the money rather than the effect spread out over time. And this is what should be happening on all the models that we create. It needs to lower the credible interval and help us achieve a model that has a low uncertainty. In this case, by the way, even though it has 60% R-squared, etc., it has a lot of uncertainty. Now, analyzing the diminishing returns curve and the ad stock effects, we want to start planning the budget. If I saw this model personally with Cassandra, I wouldn't use the budget allocator right away. But for this purpose and for this video, I'm going to use it. What I want to see how to plan next month's budget. So what I do is we get the last 4 rows, the last 4 weeks of media variables, and I sum the spend in order to understand how much I've spent in the last 4 weeks. And I've spent 32,733 euros. Now, what I do is I call the budget optimizer and I tell them to use the last 4 weeks, because what it does is we need to define the time frame of the past when we want to simulate scenarios. So we select the times in the past, so the last 4 weeks. We insert the same budget and we give the constraints to the model. And in this case, I didn't want to go too crazy. So for this reason, we went from 30 to 20% upper and 30 to 20% lower. We don't want to go and be so crazy. So we simulated these scenarios, and what we realized is that this is the non-optimized data. And you can call it by calling the optimization results dot non-optimized data. In here, you can find that with this budget, we get 185K of incremental revenue and an ROI of 5.66. While with the optimized data, with the optimized budget allocation, we get 197 incremental revenue with the same budget and a 6.02 ROI. And I didn't plot it, but you can actually check here step by step how the distribution went. This last part is going to have a dedicated video in order to unlock all the insights that we can actually have from Meridian and see what we can do with the budget allocator. So hopefully this video helped you understand how to model national model using Meridian and help you understand what are the steps that we need to do before actually interpreting the insights and implementing the decisions that we have. Thank you a lot for watching these videos. The next videos are going to be likely related to the geo-hierarchical model, Meridian and budget allocator, and playing a little with all the nitty-gritty priors that we can actually implement inside of the model and Meridian. So thank you a lot for being with me so far. Thank you.